In this video, I will explain the scope of engineering mechanics. Mechanics is the oldest branch of physics. Being a branch of physics, it deals with effects of forces on objects. What kind of objects that remains to be seen. Engineering mechanics is a branch of mechanics. So what kind of objects are studied in engineering mechanics? The answer to this question will precisely define and fix the scope of engineering mechanics. I will answer the question shortly. Concepts that are basic and central to the study of engineering mechanics are space, time, mass, force, particle, and rigid body. These are explained in separate individual videos, links to which are provided below this video. It is highly recommended that you make yourself familiar with them. Let us see how mechanics is further subdivided based on the size and the speed of the objects. These are also known as realms of mechanics, and there are total 4 realms. The first one is classical mechanics. Classical mechanics deals with the objects of size that we can see by naked eye, and these objects are either at rest or moving with the speed that we experience in our routine life. Some of the real examples or systems that are studied in classical mechanics are bridges, dams, trains, planes, or planetary motion, etc. Quantum mechanics deals with objects that are at rest or moving at a speed same as that of objects in classical mechanics, but the size of the objects is very small, that is, not visible by naked eyes. For example, subatomic particles. Special relativity deals with the objects of regular or normal size, same as that of classical mechanics, but their speeds are near to that of light. Last is quantum field theory, which is relatively new, which deals with the objects that are both tiny and moving at speeds near to that of light. Classical mechanics, which is based on Newton's laws. Hence, the classical mechanics is also known as Newtonian mechanics. Engineering mechanics is a part of classical mechanics, so let us dive deeper into the classical mechanics. We are particularly interested in digging the classical mechanics and finding out the scope of engineering mechanics. Here is the same diagram as on the previous slide with only one realm, that is classical mechanics, displayed. So let us see how classical mechanics is further classified. The next subdivision of classical mechanics is into solids and fluids. The branch of classical mechanics that deals with liquids or gases, collectively known as fluids, is known as fluid mechanics or mechanics of fluids. The solids are further subclassified into solid objects that are rigid and solid objects that are deformable. Rigid objects or rigid bodies undergo negligible or no deformation under the action of an external force. Consider any 2 points on the rigid body. Distance between them does not change under the action of an external force. In real life, however, all bodies deform to a lesser or more degree, but for some analysis, small internal deformations can be neglected. Deformable bodies, however, undergo significant deformation under the effect of external forces acting on them. Branch of classical mechanics that deals with deformable bodies or solids is known as solid mechanics or mechanics of solids or strength of material or mechanics of materials. There are several names, but all of them essentially refer to the mechanics of deformable bodies. Classical mechanics that deals with rigid solids or rigid bodies is known as engineering mechanics. Engineering mechanics is further subclassified into statics, which deals with rigid solids that are at rest, for example bridges, roof trusses, beams, etc., and dynamics that deals with rigid solids that are in motion, for example planets, projectiles, roller coasters, cars, trains, robots, etc. Let us see how the sub classification reduces the scope of engineering mechanics. First, it is a part of classical mechanics. This restricts the scope of engineering mechanics to the objects seen by naked eyes, and they might be at rest or moving with speeds encountered in everyday life. Next, it deals only with solid objects. However, forces exerted by fluids on these solids are also studied in engineering mechanics, for example, dams. Furthermore, it deals only with rigid bodies or rigid solids, which further reduces its scope only to objects that do not undergo deformation under the action of external forces. So this is the answer to the question, what kind of objects are studied in engineering mechanics?